Starting with the introduction of our group members, Aditya Chopra, Mansi Tripathi, Megha, Pranjal Sharma and Athar Mulmule. The topic of this video is microwave plasma reactor. What is a microwave plasma reactor? A microwave plasma reactor comprises a reactor chamber, a microwave resonant cavity located within the reactor chamber, a waveguide for conveying microwave radiation to the resonant cavity. The waveguide have a convergent tapered portion, means for forming an electromagnetic standing wave within the resonant cavity from the microwave radiation for initiating and sustaining a plasma within the resonant cavity. The resonant cavity having a glass inlet and a glass outlet and conduit, meaning extending from the gas outlet for containing a plasma conveyed from the resonant cavity with a gas flowing from the gas inlet to the gas outlet. The invention relates to a microwave plasma reactor that is particularly adapted to form an enlarged symmetric plasma for symmetrically processing large substrates. Given is the picture of a microwave reactor showing different parts of the reactor. Microwave generated plasmas are used in many deposition, etching and substrate processing operations. Microwave plasma torch for decomposition and steam reforming, CNT synthesis on steel strips, etc. are the basic applications of microwave plasma. They have huge breadth of applicability such as solid phase synthesis, solid supported reagents in solution phase, synthesis scale up, DMPK tissue extraction, proteomic triptych digest isotope tagging, parallel synthesis, solution phase synthesis. Now coming to the analysis of hydrogen plasma in a microwave plasma vapor decomposition reactor. The basic aim of this analysis is to build a numerical model of hydrogen plasma inside a microwave plasma chemical vapor deposition system. As we know that the use of carbon nanostructures such as CNTs, graphite sheet is growing day by day. So is the demand, their availability at cheaper rates. These materials being used in the field of engineering and biosciences because of their suitable mechanical, thermal and electrical properties, there is a need for synthesizing high quality carbon nanostructure. Chemical vapor deposition is a method for producing such materials. In this, gas molecules dissociate in a reactor and recombine to create a material film on substrate. MPVD is one of the commonly used CVD processes. The first step of microwave plasma chemical vapor deposition is the introduction of pure hydrogen into the reactor. The electric field generated by the microwave ionizes the hydrogen, igniting plasma in the reactor. The next step is the introduction of methane after the reactor reaches a steady state. Methane dissociates in the presence of plasma, resulting in the deposition of carbon on the substrate for the growth of various carbon nanostructures. The growth rate and quality of carbon nanostructure depends on the number density of atomic hydrogen and concentration of certain precursors of surface of substrate, which in turn depends on the operation conditions. By simulating on MATLAB, we obtained the graph for ln I lambda raised to the power 4 by S j prime j double prime and Ej. That gives T rotational as 91 Kelvin approximately. The frequency of the plasma is given by omega p is equal to under root E square Ne by epsilon naught m. And by MATLAB simulations, we obtained omega p equal to 2.25 into 10 raised to the power 10 rpm. The presence of plasma in the domain changes the material properties of the system by increasing the conductivity of the gas. The plasma properties are evaluated as the plasma is generated by microwaves. The radiation must be able to penetrate into the plasma in order to ionize the molecule. This happens only when the following condition is satisfied. Omega p square is less than equal to omega square plus Vm square. The graph between collision power, loss of electrons and electron temperature obtained from MATLAB simulation for Es is equal to 8.9 electron volt. For obtaining the temperature gradient plots, we solved the heat equation, that is divergence K into gradient T plus Q is equal to 0. In this code, we have calculated Q generation term of above equation using values obtained earlier. Then we solved this equation using PDE toolbox of MATLAB. The results obtained from the same are shown below. Thank you.